Hi guys, in this video I'm gonna introduce my own actuator that I designed from scratch. I designed it aiming for my future humanoid project. For the build, I used 3D printing and CNC machining. I was able to manufacture metal parts easily, thanks to JLCCNC. Now, I'm gonna show you the assembly process with some explanations. First, what is QDD actuator? It stands for Quasi Direct Drive Actuator. Here's the thing. Motors usually cannot produce high torque on their own, so they need a reducer to get high torque. Traditional robotic actuators used very high gear ratios. By the way, there is a problem with that. They have too much reduction to respond well to external interactions. It implies that robots cannot interact safely with humans. They could actually hurt people because they are too stiff. So, to get responsiveness, we can lower the reduction ratio, for example from 1 to 10 to 1 to 3. Then, to sustain the torque, we can make the diameter of the motor larger. Because the larger the diameter motors have, the more torque they can produce. Thus, I adapt this concept to my actuator. It has a 1 to 10 reduction ratio and a large diameter stator to ensure high torque. These are components of my actuator from JLCCNC. Approximately, it consists of 5 main parts. Let's start with cycloidal gears. Cycloidal drives have a high robustness and low backlash compared to planetary gearboxes and harmonic drives, so I select cycloidal drive for my actuator. The output shaft have rollers like this, and these rollers make cycloidal gears rotate much more smoothly. And this is a dual desk setup. This design prevents the oscillation caused by the eccentric shaft. 2 cycloidal gears are kept in an inverted phase, exactly 180 degrees apart. This is because they have to cancel out the eccentric forces to balance the system. Next, I put the gearbox into the housing, followed by the stator that I wound by myself. I used 0.4mm enameled copper wires for my stator, and I wound 6 wires in parallel 5 turns each around BLT's motor winding configuration. Make sure to fasten everything tightly. Don't forget to lubricating the gears. We have to do this. It is essential to prevent wear from friction. And finally, the reducer is fully backdrivable. This makes it highly sensitive and responsive to external interactions. Then I installed the rotor. I used 42 pieces of N52 permanent magnets for this rotor. They are placed in an alternating pattern, North Pole, South Pole, North-South like this. To fasten them to the rotor, I used JB weld glue. This small piece is a permanent magnet for the magnetic encoder. It senses the north and south poles to calculate the position, angular speed, and acceleration of the rotor. Then put the housing into my actuator. Finally, I have assembled all of them. For the motor driver, I'm using Motors Controller C1, which is the only off-the-shelf part in this actuator. After some calibrations, finally I can control it. Then I tested some control modes, torque control and position control. couldn't be able to accurately measure the maximum torque and speed this time, so I will cover that in the next video.